Exercise 5. We begin by going to File, New. Select Assembly, as this will be our first assembly created in this class, and hit OK. Hit the green check mark under Begin Assembly on the upper left-hand side, or hit the red X. And now we need to save this. Let's just save it right now and call this E5. Another thing you might want to do is go up to the top next to where it says SolidWorks and the little arrow to the right of it, and go to View and turn on Origins. The origin is a very useful thing inside Assemblies and inside of anything. It's your zero marker in space, and we want to build our assembly around that origin. The next thing we're going to do is we're going to go to Insert Component up at the top here. Click on Insert Component, and here we can browse down below. So hit the Browse button and go to your SolidWorks Fundamentals, Sample Files, Exercise 5. And what you're looking for the very first part is called the bracket. Select the bracket and hit Open. Now you can see a preview of the part. What you want to do is move the tip of your pointer onto the blue origin in the middle of the screen, and it will snap your part's origin right onto it. Click to drop it. Now by doing that, the very first part, and only the first part that you drop into an assembly, is automatically fixed or locked down in space. Doesn't matter if you drop it on the origin or not, it will be locked down. And the reason for this is that you could build the other parts around it and without it moving by accident. Now you can tell this is locked down by the little F in parentheses in the feature tree where it says bracket here. If it has a little minus symbol, that means it's not fixed. In other words, it's floating and it can be dragged and moved around. Right now if I try to grab this part, it would tell me the selected component is fixed, it cannot be moved. Usually you could just drag it with the left mouse button depressed. Can't do that on this one. What we need to do next is we're going to introduce another part. So oh, by the way, before I go that far, if you did want to float this part, you could right click on it and there is an option for float. I do not suggest that for this part. Leave it fixed for right now. But you could always go back and fix it if you needed to for some reason, or you could fix a different part. SolidWorks is very flexible and forgiving in that if you make a mistake, you can fix it pretty easily. All right, now let's introduce another part. Let's go to Insert Component, go to Browse, and this time we'll introduce the yoke male and just drop that next to the other part. Now you can see this one, if you grab it with the left mouse button, you can drag it pretty much anywhere. It even goes through the other part. There is collision detection for dynamic testing, and there is also static interference detection for, of course, static bodies. We'll look at both of those in just a moment. But let's look at this. When you move this part with the left mouse button, you can do that. There's also a Move Component tool up here at the top. If you click on that, you'll see there's Rotate Component. Rotate allows you to rotate around the centroid of the object, so if you need to flip it over upside down or whatever to get it easier to get into whatever you're trying to attach it to, you can do that with the rotate. Otherwise, there's just the Move component, or just drag it with the left mouse and press without having to select the icon. Now what we want to do here is we want to get this locked in to this hole here. Now when you're applying mates inside SolidWorks, it's much like when you're sketching in SolidWorks and you have relationships. There's common elements in geometry, coincident, tangent, perpendicular, parallel, things like that. You could add those same things to the 3D models here that you're adding in the 2D sketches of your models on the part file end. What I like to think of it this way is you kind of select the faces or edges that you would add glue to if this was a plastic model that you bought at the store. So what I'm going to do here is, first of all, there's the paperclip icon. This is mate. This is what you're going to be using quite a bit to attach these parts, to paperclip them together, so to say. So select the mate, and it's asking to select the entities to mate. Well, we want this shaft. Be careful not to select the flat. Select the shaft, and then select the hole on the bracket. And it will align to it, and you'll see a whole list of options here. One of them here is concentric. By default, it knew that that was probably the most logical choice, and it's selected for us automatically. If we don't want it, we could select something else. But concentric is what we want, so we'll apply that with the green check mark. If for some reason it's upside down, the flip mate alignment tool here will adjust that. It will rotate it 180 degrees. Let's hit the green check mark to apply. Now as we take a look at this and grab it, you can see that it's locked down some of its degrees of freedom. It can no longer move left and right. Instead, it swivels in place as it has that concentric relationship, and it could move up and down. So the next mate we want to add is between this face here and the underside face of the bracket. And you could either add a parallel at a distance, or just coincident, which is face-to-face contact. In this case, we'll do face-to-face contact. We'll look at those others in just a few minutes. Hit the green check mark to apply. Again, you're removing degrees of freedom here. Can no longer be moved up and down. It just swivels in place. Now, depending upon your application, you might want to actually leave some of those, the ability to rotate it dynamically, so you could do some testing on it or analysis. Otherwise, you can lock it down completely. The next best way to lock this down would probably be to select one of the flat faces in the leg, and then this flat face here, and maybe make them parallel. Therefore, it wouldn't be able to rotate anymore. But we don't want to do that here. We want it to actually rotate. So let's hit our green check mark for just a minute there to apply that. Now let's introduce another part. Let's go back to Insert Component, hit Browse, and we'll bring in the spider. Let's drop the spider right there. Now, I want to show you some of the other functionality that we have here. You can actually test this if you click on the part, or if you go to Move Component. On the left, you have options that we didn't look at earlier. One of them is the standard drag. The other is collision detection. If you select this and drag the part, it will actually strike the other part, and it actually makes a ping sound, which you might not be able to hear on this microphone. But it highlights the faces that it's come in contact with. So this is what I was talking about when I was discussing dynamic collision detection. That could be very useful. There also is the ability to apply physical dynamics. We don't have a good example of that here. That's like if you wanted to mesh gears and have like the domino effect, so to say, where one part dragging hits another part, which might hit another part, or like a pool table with balls on it. So that's what you could use physical dynamics for. When you move one thing, it'll push the other, and so on. There's also dynamic clearance detection. This is great. I saw a great example of this used on a conveyor belt once, where they needed to see how far a part would move from the edge of the conveyor belt. And this is what you do. You select the little box, and you select the components you want to test between, and then hit resume drag, and as you drag it, you'll see dynamically a dimension appear as to how far it is from the closest points between the two geometries. There's another option attached to that, which is a little stop sign. You can tell it to stop at a specified distance. Maybe I want it to stop within a 1/4 inch. Now if I drag this, when it comes within 0.25, it stops. Okay, let's go back to attaching this. So what we could do here is we could go to the mate. We could select, in this case, let's select this face and that face. Now in 3D, it might be somewhat difficult to grasp what it's doing here. But if you look closely enough, if we rotate that so both lines line up, we can see that there's a condition of alignment that's unacceptable. We need that block to be on the inside of those legs. So this is where we would use that flip mate alignment option. And now we can select this hole and mate it to that hole. Be careful not mate perpendicular holes, as you'll get a little error message. If you do get an error message ever, or you made it and it doesn't move, stop. Don't hit the green check mark. Actually hit the undo button here. If not, on the left, there's the ability to go back and delete it. We'll look at that in just a few minutes. But right now, we'll apply that. Let's take a look at what we just did here. Now, if I grab this part, we could see that it could rotate in place. If we grab this, it moves still. So we have some degrees of freedom remaining. Let's go ahead and add some additional parts. Instead of using insert components, you could also right-click on the start menu of Windows, which you can't see on my screen, and you could go to the Explorer, Windows Explorer, and we could actually locate the files this way. And I'll find them right here. We'll go to the sample files, exercise 5, and we could see they're all listed there. And let's grab one and drag it in. Sometimes you can see little pictures. I must have mine deactivated of each part, but we could read them and find out what they are. Actually, let's go to thumbnails. No. Okay. Now, the next part, I know what I want, is going to be the yoke female. So I'm going to grab that from Windows Explorer and drag it right in. So that's another way you could actually drop in parts. You don't necessarily always have to go to the Insert Component tool, which is easy. You could actually just have your Windows Explorer open as a little library to pull parts out of. Okay, we're not going to put the pins in just yet, but we'll attach these components to one another. So let's go to the Mate tool. We'll select this face, and we'll mate it up to this face right here. Oh, didn't want that edge. Click on it again to deselect it. Now, here again, we have an issue. We have to select the flip mate alignment. There also is the option right here on the left, a toggle between the two. That looks pretty good. Apply that, and then select the holes. Now, to get this to go down, flip it around, you just grab it after you hit escape or whatever. Drag it down. Then you can click this. And what we need to do is mate this face to that face there. So again, let's go to the Mate tools, select this face, and that one right there, and it doesn't move automatically. SolidWorks doesn't know what to do. As a matter of fact, it gives us a little error message here. The default mate coincident would over-define the assembly. Please select a different mate type below. So we can select here or there. Well, what this probably is, what's happening here is that we're not exactly sure what distance there might be between these two faces. Coincident is the default, and coincident is a face-to-face contact. And if it can't do that, it's going to error out. So perhaps parallel might be a better option. Let's select that. And sure enough, it is. And the reason for that is, like I said, there's a small little distance gap between those two parts. And if we go to a right side view, we should be able to see that. And sure enough, there's the distance gap. So that's the type of warning you'll get. Okay, now we need to add the pins. Again, we could bring up Microsoft Explorer. We could drop in these pins. We want the U-joint pin 1. And okay, we have a little bit of a problem there. Sometimes it's not always safe to use use Explorer out of Windows. In this case, we'll go ahead and try a different method. We'll go back to our probably because I had the mates on. We could just go back here to Insert Component, Browse, and bring it up this way. And in this case, we'll just drop in the U-joint pin 2. Drop one there. And let's bring in the other one too. There's U-joint pin 1. There it is. We'll actually need a double a copy of this red pin, as there's going to be 2 of them in there. But let's do that in a moment. Let's first add the blue pin, this face of the shaft, to this hole. Now, we need to push this pin in, but what mate should we use? Well, let's see what SolidWorks suggests. Select the end face. We need that end face flush with this face here. And look at that. It picked tangent for us automatically. Okay, let's go ahead and add this one now. Select that face to this face. Now be careful, if you add a tangent mate to this, from this face to this, or what looks like over here, it might actually stick on the outside like this. Okay. Again, flip mate alignment might actually give us more problems than usual. It usually does. I don't even want to touch it, as a matter of fact. Well, let's go try it. And it worked, actually. Sometimes it gives us problems. 2008 seems to have fixed some issues with that. All right, now we need to make a copy of that. Here's how. You could do it several ways. You could grab the U-joint pin from the feature tree, holding control, drag it in, or grab the actual surface of the model in the view screen, holding control, and drag off a copy. Watch this. Hold control, grab the surface of the pin, drag it out wherever you want to drop it, release the mouse button first, then you could release control and it makes a copy for you. If you do it in reverse order, it will just actually move the pin to a different location. So now we go back to mate, select this face to that face, hit apply, and this face to that face, hit apply again. Hit the green check mark under mate, and let's test this out. Grab this top surface and rotate it. If it rotates, you're in good shape. If it doesn't rotate, you might have a little red marker here. The difference between a part file and an assembly file isn't much, other than the feature tree has these little 2 paper clips, and you really don't model the same way. You're actually putting together parts quite a bit in here. But you can model inside of an assembly. It's called top-down assembly modeling, which we'll look at in a few weeks. But if you have any sort of error messages down here, these are the mates that are in this model. You could click on the little plus symbol, and you can see all the mates. As you click on them, it will highlight the faces of each on the actual model. So you could determine whether or not you want it, or if you want to edit it, you could click on Edit Feature. It will take you back. You could flip the mate alignment. You could choose a different option. You could even choose different faces. Or you could just altogether click on it and hit Delete. Remember, if you have an error message, don't keep adding the same mate over and over again. It will just keep compounding your problems. Usually just delete the ones that are red or marked red from the bottom up, and you'll be in good shape. And then re-add them as necessary. The next step here is we want to introduce a sub-assembly. So far we've worked inside of an assembly here. We haven't introduced any sub-assemblies. They work the same way as a part file. If we go to Insert Component, go to Browse, instead of a part file under Files of Type, hit the little arrow there and find Assembly Files. And you'll find something called the Crank Assembly. Select it and hit Open. You can see you can move this just like you would an individual part file. And what we want to do is we want to lock that in at the very top. But look at the feature tree. It is a crank assembly. It's even the blocks indicate green and yellow versus just yellow indicates parts. Hit the little plus symbol to the left of it, and you'll see there's a crankshaft, the crank arm, the crank knob that make up that. So let's begin. Let's first start by getting this in alignment. So we'll go to the mate, select the shaft here, and select this shaft. Doesn't matter if they're intersecting. Just drag it up. If for some reason you wanted to test if there was an interference, there is interference detection here. Let me just, as a side note, show this to you. I just hit Escape, and here we have actually, you know what? We'll go back to that in just a minute. Let's finish this off. I don't want to get sidetracked. Okay, what we do here is we already have an alignment concentric, but we need to mate the flats, this flat to this flat here. So let's go back to mate, select that face and this face. And we get a little message saying the default mate type tangent would overdefine this. Apparently, if I look at this closely enough, look at what's highlighted. I accidentally selected that shaft. So let's deselect that and make sure we select the right face. And there it is. Hit the green check mark to apply. Now what we want to do is we want to mate this to the top face, but have a little bit of a distance gap. In the past, we've always made it coincident or parallel, but we've never specified an exact distance. This is how. Select that bottom face, and then select this top face. Right now it's defaulting to coincident. To override that, select distance here or over here, and type in the value. In this case, we'll type in, let's say we know what it is in metric, but we don't know what it is in English. We can actually type in 1 mm for millimeters, and it will do the conversion for us. In this case, 0.03937 is the distance, so that's 1 millimeter. Just know that you could type in those types of values in any dialog box inside SolidWorks, whether it's a dimension or whatever. You could type in the conversion of whatever you have, and it will automatically convert it for you depending upon the system of measurement that you're using. Just make sure you type in, if it's in inches, type in lowercase in, or you could even do the little quote, or for metric, it should be mm lowercase. You could even type in equations into those little boxes too, like 4 plus 3. Hit enter and it will automatically do the math for you. Okay, now let's test this. If you grab the arm at the top and rotate it, everything should move together. If something's not moving, that usually means it's missing a mate. And you could go down to the mate groups and locate it, or try and figure out where you left off, or ask the instructor for help. And that concludes this lesson, exercise 5.